In this section, we are going to talk about R square, F square, and Q square. Now, what is R square? R square statistics explains the variance in the endogenous variable explained by the exogenous variables. Now, simply speaking, it means how much change or how much variance in the dependent variable can be accounted by one or more independent variables. Let's say, for example, there is a variable y that is influenced by x1, x2, and x3, and it has a r square value of 0.623. So the r square value of y is 0.623. Now, in order to interpret this would mean that 62.3%, if you multiply it by 100 and change it into percentage, this would be 62.3% change in the dependent variable y can be explained by x1, x2, x3. Now, in order to make it easier to interpret, look for the arrows that are pointing towards the dependent endogenous variable or variables. Now, we are going to look into this using SmartPLS. Now, there are different values of R square that we get. How do we interpret this? According to Falk and Miller, 1992, they recommended R square value should be equal or greater than 0.10, that is 10%, in order for the variance explained of a particular endogenous construct to be deemed adequate. Cohen, however, in 1998 suggested three different values: 0.26 for substantial, 0.13 for moderate, and 0.02 for weak. Chin, again, 0.67 for substantial, 0.33 for moderate, 0.19 for weak. However, recently, Here et al. In their book suggested that it should be 0.75, 0.50 or 0.25 for endogenous latent variables, and they are described as substantial, moderate, or weak, respectively. So what is F square? A variable in a structural model may be affected or influenced by a number of different variables. We are going to practically look into this as well. Now, removing an exogenous variable can affect the dependent variable. So F square is the change in R square when an exogenous variable is removed from the model. So whether that F square is substantial, moderate, or weak. This means that change in that R square would be substantial, moderate, or weak. So F square effect size is greater than 0.02. This means that it has a small effect. So removing that exogenous variable will have a very smaller effect on the R square value for the endogenous variable. 0.15 for medium and greater than 0.35 for large, according to Cohen, 1988. And lastly, Q square. Now, Q square is for predictive relevance. It measures whether a model has predictive relevance or not. If the Q square value is greater than 0, this is good. Further, what Q square does is it establishes the predictive relevance of endogenous constructs. Q square value greater than 0 indicates that your model or your values are well reconstructed and that the model has predictive relevance. A Q square value, as mentioned earlier, shows that the model has predictive relevance. In order to find out the Q square value, run blindfolding procedure in SmartPLS. Now we are going to practically look into R square, F square, and Q square to find out whether or how they can be done in SmartPLS. Okay. Now this is a simple model that I have built for this particular video. Now, if you go to calculate and you run PLS algorithm, all good, start calculation, and here are your results. These are path coefficients, but in this case we are interested in R square first. So the R square value is 0.719. Now this is for just one variable because we have got just one dependent variable, one endogenous variable. This is 0.719. all arrows are pointing towards just one variable. So you've got one R square value. This means that 71.9% change in loyalty can be accounted to satisfaction, service quality, corporate social responsibility, and image. So this is how you find out R square value, and this is how you interpret the R square value. Just underneath the R square value, we've got F square value. Now if we look here, we've got one in green, we've got two in black and one in red. So if we remove service quality, this will have no influence on the R square value. This is green. This means that this will have, in this case, this is a moderate impact because it's greater than 0.15. And these one will have a weaker impact on the R square. Now, whether these influences are significant or insignificant, this can be achieved by running the bootstrapping procedure. So we go to calculate, bootstrap, and let's say complete bootstrapping and all good. For now, just for the sake of this video, let's do 500, path and start. Does take some time because you've got some variables in there. Now here are our results, and if you go to R square, so this R square is significant, and if you go to F square here, and this shows that this removing image will have a substantial impact on the R square value. Removing CSR will have an impact on R square value. Removing satisfaction will have an impact on R square value, but removing service quality will not have any impact on the R square value of the endogenous variable. So you can remove this variable from your model if you want to improve your model and the R square value maybe. Now moving on, let's run Q square, the blindfolding procedure. Go to calculate, and here is blindfolding procedure. The omission distance, this is the systematic pattern of data point elimination and prediction in the blindfolding procedure, depends on the omission distance. The user must select a value for D when running the blindfolding procedure. Suggested value is between 5 and 12. We'll keep it to 7 as default, path, and just start. So let's see if our model has got predictive relevance or not. And in this case, the loyalty has Q square value of 0.410, which is greater than 0.35. So there is substantial predictive relevance in our model. 0.41 is substantially higher than 0 and it is greater than 0.35. This means that our model has got predictive relevance. So you can just simply report it and write in your research thesis or your paper that your model had predictive relevance since the Q square value was greater than 0. I hope the video would have clarified the concept of R square, F square and Q square. Thank you very much.